So we are talking about 19.2, question number 2. We're on page 298 in your textbook. Okay, if you're following along, you should have completed this problem on your own already. Even if you were just kind of trying to think through it, you're not quite sure what your answer is, that's okay. I'm going to talk through this a little bit, and specifically I'm going to talk through one strategy of solving the system of equations. I'll mention a couple of other ones. Okay, so again, we're comparing orchard A and orchard B, and which one would be the better deal for our students to go, for the teacher. So I'm looking at 9 times n plus 3 equals 10 times n plus 1. This is what the teacher writes. And then she also writes the inequality that was given to us. What does n represent in each statement? Well, if we refer back to the prompt, okay, we know that orchard A costs $9 per person, whether it's a student or a chaperone, and we're required to have 3 chaperones. So n is going to have to represent the number of students going on the field trip. And that's the case for both sides of our equation. N represents the same thing going to orchard A, or orchard B is representing the number of students going. Okay. When we have the equation versus the inequality, we want to know, what does that mean? That means that the cost of going to orchard A equals the cost of going to orchard B. Okay. Now, what does the solution to this inequality tell us? It's going to represent, since this is orchard A and this is orchard B, right? This is saying that orchard A is going to cost less than orchard B. So when we solve that inequality, it's going to give us the number of students for which it would be cheaper to go to orchard A than it would be to orchard A than it would be to go to orchard B. So it says, graph the solution to the inequality on a number line. Be prepared to show or explain your reasoning. Now, a couple of different ways that you can do this. You can start by guessing and checking, plugging in values that would make sense, and kind of work your way then up to a point that doesn't work. We did that in the warm-up yesterday, so that's one method. The method I'm going to show is actually solving the equation, okay? Because if I know when they're equal, that's going to give me a boundary point where I can see which one would be better. Okay, so it's going to kind of give me that like divisive line. So I'm going to start by solving here. I'm going to use the distributive property. There are a variety of ways, as you guys know, to kind of start these solving problems. Okay. And I'm just working through showing all of the steps to solving. Get one in. So I'm getting that at 17 students, they are equal in price, either orchard A or orchard B, okay? So what I need to do is I need to figure out on which side of that, which side of 17 is orchard A going to be cheaper, okay? So if I were looking at my number line, right, I would throw this on here, 17, 18, 19, and so on, right? You would keep numbering that. So if I'm looking at 17, I'm going to put my circle there, okay? And then I have to figure out which values make my inequality true. So I'm going to take a number smaller than 17, and I'm going to plug it in for n, and I'm going to see what solution I get. Okay, so I'm going to plug in 16. And I'm going to see if I get a true statement. skipped ahead here. 171 is less than 170. That is a false statement. Okay, so I know that this is not true. So 16 students going would not result in Orchard A being cheaper than Orchard B. Okay, Orchard B would still be that $1 cheaper. So now I'm going to test out 18 to see if that's true. And again, I'm testing points on each side of that boundary that I found by solving the equation. You can see my work here, kind of squeeze it in, okay? But I can see 189 is in fact less than 190. That is a true statement, okay? So I did a test point as a representation showing that any number that I choose larger than 17, 20, 21, all the way up is going to give me that Orchard A is less than or costs less than Orchard B. So anytime that I have more than 17 students, I would want to go to Orchard A. So I'm shading to the right, representing all of those values, right? Anything to the left, 16, 15, 14, all the way down to 0 is not going to give me a solution to my inequality. And it would be a better choice to go to Orchard B for anything less than 17. Anything bigger than 17, it would be a better choice to go to Orchard A.